I'm going to walk through an exercise now on how to create a laser cutting file to create an enclosure for an Arduino Uno. An Uno is a type of Arduino. You can buy them cheap for $5 or so. And as we learned in that one video earlier, there's a great through the web app called MakerCase where we can specify the dimensions, the width, height, and depth of a box. So an Uno is about 2 3/4 inches long. So let's make our box 3.5 inches long. It's about 2.1 inches wide. So let's make it 2.75 inches wide. And let's say we want the enclosure to be about 2 inches high. And let's set these dimensions to be the inside, so we have plenty of room for our Arduino. That way it'll add the thickness of the material to the outside. Let's say we're cutting with 1/8 inch acrylic, or we're making it out of 1/8 inch acrylic, so we can set our material thickness there. That's default. If we just do flat edge joints like this is a little bit hard to hold together while you're gluing. So I like finger slots like this. And we can also play with the size of the tabs. We can make them narrower, we can make them fatter. I think fat is fine like this. We just need a few to hold it together while we glue it. And now let's hit Generate Laser Cutter Plans. We can specify the margin of how far it is from the edges of the whatever we're going to be cutting it from, what material we're cutting it from, in case we have some rough edges or ends. Vector cutting, we can set a few variables. This one is the line stroke width, or the line weight for vector cutting. We're going to be saving this as a PDF and then loading it onto Corel, which is the software that is on the computer that drives the Trotec laser cutter, which is one of our favorite laser cutters. So in Corel, we will reset this line width, or this stroke width, to hairline. That indicates to Corel to tell the computer that it should be cutting, not rastering. It should be vectoring. So we don't have to worry about this right now. We'll reset this later. And then we're not doing any text engraving. We can set the laser cutting kerf. So the kerf is the width of the cut that the laser makes through the material. If we were cutting with a table saw using an 1/8 inch wide blade, then the width of the cut would be about an 1/8 inch, a little more. But on the laser, it's much smaller, but it's not 0. And we know that it's about 4/1000ths of an inch, 0.004. And again, that previous video did a great job of showing how you can calculate this. If you don't set your kerf right, then your box might be too loose or too tight when you try to set these tabs together. So now we're going to say download plans. It's that easy. We now have an SVG vector file. I'm going to open Inkscape, which is our preferred free vector design tool. Not just free, but open source. And I'm going to open those plans. And there they are. And I'm going to set my document properties to be 24 inches wide and 12 inches high, because that's a typical pre-cut size for sheets of acrylic plastic that we laser in. It's also a typical pre-cut size for sheets of plywood we cut with. So there we go. Now if we zoom out, we can see that our pattern is in the bottom corner here. I'm going to make a new layer now. Add layer. We're going to call this the hole pattern. We'll explain what that is in a second. If we're mounting an Arduino to this, an Arduino has little holes that you can screw into. So I'd like to pre-cut where those holes will be with the laser on this pattern. And what I've previously done, I Googled Arduino hole pattern, and there is on adafruit.com, which is an electronics supply company in New York City, great company. They have the hole pattern for Mega and an Uno. Those are two different types of Arduino. This is although it is a vector, it's a PDF, it's not the kind of laserable vector that I wanted. I would just want these holes that I can copy right into our cutting pattern here. So what I've previously done is I created a file where I did in fact load in that image of the Arduino Uno schematic, or rather the dimensions, and I sized it to make sure that it is in fact the right length and width of an Arduino. And then I traced those holes in vectors. And I copied that into a layer called hole pattern. So I've now highlighted that layer. I'm going to do Control A for copy all, Control A for select all, Control C for copy. Now, making sure that I'm in my hole pattern layer here, I'm doing Control V for paste. And I'm going into Object and Group. So now, the computer is being a little bit slow. I'd like to select, there we go. And move these guys. And my recording software and Inkscape are not behaving well. Inkscape really doesn't like that much software being run simultaneously. So I'm going to stop recording, move this, and start again. So now I'm going to move these holes onto onto the part that I consider the bottom, and I'll put that right in the middle so I've got enough room for a power cord coming in, for other wires coming in and out. And now I've got a file that I can save as a PDF, and that's the format that that Corel and the Trotec like the most. I'm going to say OK. And then I can copy that PDF file to a flash drive, bring it to the computer next to the Trotec, put it in there, open it in Corel, change all these line weights to hairline, and then hit laser cut. And it'll cut out a box that I can snap together, which has pre-sized, pre-arranged holes for mounting my Arduino to. That easy. Lots of fun.